All right, welcome Genesis International College students. We've got a fantastic explainer lined up for you today. We're zeroing right in on topic 2, perform basic calculations. So consider this your ultimate on-the-job guide to mastering the math that's going to literally build your future.
Look, as a vocational student in building and construction, you already know your skills are your livelihood, right? You're learning to work with your hands, your tools, your materials. But today we are laying down the absolute foundation of your trade's career. We're talking about the mathematics that actually makes everything else possible.
Here's our blueprint for today. We've got 1, the importance of accuracy, 2, rules of the math game, 3, calculating 1D perimeter, 4, calculating 2D area, 5, calculating 3D volume, and finally, 6, final checks and practical tips.
Section 1. The importance of accuracy, building a strong foundation.
Okay, be honest with me for a second. If you ever sat in a high school classroom just staring at a whiteboard, wondering when those random numbers would actually matter in your real day-to-day life, well, I've got some news for you.
As your course materials plainly state, that moment has officially arrived. Out on a real, working construction site, math isn't just some abstract concept. It's quite literally a tool. In fact, it is just as crucial as your power drill, your laser level, or your tape measure.
Let's break down the real-world stakes here. So much of what you're going to do throughout your entire career relies 100% on your ability to take perfectly accurate measurements. Poor math, it leads to botched finishes, completely blown-out budgets from wasted materials, and massive drops in your efficiency. Getting this right is exactly how you save time, save money, and build a rock-solid reputation for quality craftsmanship. Section 2. Rules of the math game. Setting the parameters. So, before we measure a single thing, we've got to understand the absolute rules of the game. Math has a strict order, and breaking it, well, it breaks your build. If you just punch a long random string of numbers into an app, you are probably going to get a completely wrong answer. You absolutely must follow this order of operations. First, calculate whatever is inside your brackets. Next, handle all your multiplication and division. And only at the very end do you do your addition and subtraction. It's a non-negotiable sequence. And to make sure you're following those steps accurately, always keep a digital calculator handy or, the calculator app on your phone or smartwatch. You're going to rely on this constantly to double-check your math and figure out exact material quantities before making a single, irreversible cut. Remember the golden rule. Measure twice, calculate once, then cut.
Section 3. Calculating 1D, perimeter, the outside edge.
Our very first dimension is the perimeter. This is simply the total linear distance running right around the outside edge of a shape. You're going to use this measurement all the time on site. A perfect example is calculating the amount of formwork required to hold a simple concrete path. You really need to know that exact straight-line distance around the space to order your timber correctly. Now, the absolute simplest form of this calculation is for a square. Because all 4 sides are exactly equal, you don't need to measure every single one of them. You just take the measurement of one side, the length, and multiply it by 4 to get your total perimeter. Quick, easy, and super efficient. But what about circular perimeters? In construction, we call the perimeter of a circle its circumference. To figure this out, we have to introduce an irrational number you might remember from school: pi. Now, don't worry, it's a lot more helpful than it sounds. Pi is just the ratio of the circumference of a circle to its diameter. And here's the absolute magic of pi. No matter how massive or tiny the circle is, this ratio never ever changes. It's a constant you can bank on. Because pi is an irrational number, its decimal form technically goes on forever. But out on the job, we need practical numbers, right? So in your Genesis International College resources, we round it off to 4 decimal places. That gives us 3.1416. Seriously, lock this number in your brain right now. You absolutely must memorize it for all circular measurements moving forward. Section 4. Calculating 2D, area, covering the surface. Now we're scaling up to 2 dimensions, the area. This tells us the total size of a flat surface. Whenever you hear things like square meters or square millimeters, boom, you're in 2D territory. Area calculations are absolutely vital for determining the quantities of materials that will cover a space. Think about ordering tiles for a bathroom, laying down timber flooring, or figuring out exactly how many sheets of plasterboard you need for a new wall. While squares and rectangles are a straightforward length times width situation, other shapes require a bit more finesse. Take a triangle, for instance. To find its surface area, you multiply the base of the triangle by its height and then simply have that result. Easy enough, right?
Section 5. Calculating 3D. Volume. Filling the space. All right, finally, we build up into the third dimension. We've gone from the outside edge to the flat surface, and now we're filling the space inside. Expressed in cubic meters, volume calculations are your ultimate go-to for earthworks and concrete. You use these specific calculations to figure out exactly how much soil needs to be excavated and removed from a site trench, or precisely how many cubic meters of wet concrete are going to be required to fill up your freshly laid formwork.
And as things get a bit more complex, your formulas actually start to layer together. Let's say you want to find the volume of a cylinder. Imagine you're pouring a massive cylindrical concrete pillar. First, you have to calculate the 2D area of the base circle using our good friend pi. Once you've got that flat area, you just multiply it by the total height of the pillar, and presto, you've got your 3D volume. To summarize all this perfectly, your course materials include this awesome cheat sheet. It neatly differentiates between your 1D, 2D, and 3D calculations on site. Keeping this logic straight in your head is going to prevent you from accidentally ordering, say, square meters of fencing when you actually just needed linear meters.
Section 6. Final checks and practical tips. To wrap up this explainer, let's bring all this theory straight into the real world. Because out on a busy site, perfect math requires practical adjustments. First off, always show you're working. If a measurement looks a bit off, you need to be able to retrace your steps to find the error. Second, you obviously can't order half a brick or a tiny piece of a plasterboard sheet from a supplier, so you always round up. Third, you'll be using percentages constantly to mix extra substances or add a buffer for waste margins. And finally, you have to factor in weight per cubic meter to make absolutely sure you aren't exceeding safe material handling limits. I want to leave you with this final thought. If basic calculations determine the ultimate success of your craftsmanship, the safety of your site, and the efficiency of your materials, isn't it time to start treating your calculator as the absolute most important tool in your entire tool belt? Master these calculations, and you are well on your way to truly mastering your trade.